Hi guys, I'm going to talk about problem solving question 3 for this diagnostics. I think one of the main problems with it was that unfortunately there was a slight typo in the question and that this should have been a plus. If you did it without, then you would have just got a much more complicated answer, so apologies for those of you who persevered with this one. But the reason why I've chosen it for the diagnostics is I still think it's quite an important question to look at. Especially in our crosshairs, our surds wasn't as good as it could have been, so that's why we're just spending a little bit more time focusing on it. So this question was a simultaneous equations question. It had quite a fun little trick in it to help us solve this. And one thing that I'm noticing when I'm looking at these is that the second equation is much more complicated than the first equation. So what I decided to do is to take equation number 2 and just do some manipulation in it. And what I'm noticing is that I have minus 2 root x here and minus 3 root x and root y on this bit here. So I'm thinking, if I was able to make that positive, aka put it on the other side, then I can just replace it with 5 from the previous question. So that was the first thing I did, was expand out these brackets here and then get those bits over to the other side. So I have got 5 root 3x, and then the minus root 2x I'm going to put as a positive root 2x on the other side. Then I've got 5 root 2y, and then the minus root 3 I'm going to put positive root 3y on the other side, and then just keep the plus 10 root 6. I could have taken it over, but again, I don't want to do any more negatives than I need to. So at this point, this is where, sorry, just getting a different colour pen. Then at this point, we're noticing that this section here is just root 2x plus root 3y, which we know is equivalent to 5. So I'm now in a much nicer situation, is equal to 5 plus 10 root 6. Again, something special is happening here, and then I'm clocking that everything here can be divided by 5. So I'm dividing the left-hand side and the right-hand side by 5 to give me root 3 plus root 2, so that should be 5 root 3x, plus root 2y is equal to 1 and 2 root 6. Just dividing through everything there. Now I'm in a much nicer position to compare this to this top one up here. So in actual fact, if I now bring in equation number 1 below this, I've got root 2x and root 3y is equal to 5. You can attack this any way you want to. In this one, I actually think it's quite a good idea to go back to our GCSE style of solving simultaneous equations and actually looking at multiplying this one by root 3, and multiply this one by root 2, just looking at so that we can compare these coefficients of y, make them the same, and then subtract them. So I'm going to multiply the whole of that equation by root 3. That's nice, because when I multiply this bit by root 3, I get, so this becomes 3x and root 6y is equal to 3 and 2 root 18, remembering I'm just multiplying root 3 by root 6 there. Oh, sorry, that should be root 3 there. Lovely. The one below, when this gets multiplied, it becomes 2x, and root 6y is equal to 5 root 2. Lovely. Now I've got the same ones for the coefficients of y, so I'm going to subtract them. That leaves me with 1x is equal to root 3 and 2 root 18 and 5 root 2. So I take away 5 root 2. Not a big fan of this at the moment because the root 18 here has got a square factor, which is 9. So if I turn the root 18 into root 9 root 2, it then becomes 3 root 2, so then it becomes 6 root 2, and we get a lovely answer of root 3 plus root 2, once I've taken those 2 away there, which is the answer that they were looking for. Wonderful. Okay, Obviously remembering that simultaneous equations can't be solved by just finding what x is equal to. We also need to find what y is equal to. So we're going to substitute that into either of the two equations. It makes sense for me to put it this one, and it's just a bit simpler. So I'm going to go root 2 times what, so substituting x equals root 3 plus root 2 into equation 1. Again, just describing what I'm doing in each step. So root 2 times x, and I know that x is root 3 plus root 2. Add root 3y, and that is equal to 5. That is all from equation number 1. Expanding out, root 6 plus 2 plus root 3y is equal to 5. Taking the 2 over and taking the root 6 over, we'll give that a go. So root 3y is equal to 3 minus root 6. Divide by root 3, y is equal to 3 minus root 6 over root 3. Again, not a nice answer because I've got a surd on the bottom here. So I'm going to multiply the top and the bottom by root 3 to rationalise that denominator. Remember, at A level, you're expected to spot when a denominator needs rationalising rather than being asked to do so. So this one, I get 3 root 3 minus root 6 times root 3, which again is root 18, 3 root 2, all over the bottom, which then just becomes 3. Divide them all through by 3, and I just get root 3 minus root 2, which is a much nicer answer for y, and then that one was x. So apologies for the slight mistake on this question, but I really think that was an important question to do so. So have a look at my one here, and then the one in diagnostics, question 1, is very similar to this kind of idea. So think about the little tricks that I did, think about the processes of simplifying it first before trying to solve them. All of these things are going to make your life easier and therefore make mistakes less likely. The second question in the diagnostics is just all about modelling, a little bit more, a slightly more straightforward example of the last question on the conceptual paper that you looked at, and one worth spending some time on. Okay, hope that helps.